Tingnan natin kung tatayo.
What are you sharing with your group, Mr. Michael?
Actually, he asked why is triangle more sturdy. I explained to him that the reason why it's sturdy is because when weight is added to the top, the weight that is being carried is divided into the two poles instead of just being carried by just one pole. So that's the reason why it's sturdier. If it was a square, these parts would be softer. But not so.
So the wood is cut in different angles because the wood grains here are shown in different shapes.
It is. Is it getting absorbed again? Sige, go. Strong.
It's soft. Grainy. Yeah.
Grainy.
It's grainy. You could use these. Times 10.
But you can see here.
So that you crystals from inside the light immediately because we noticed that the water doesn't flow anywhere else. And then we thought that the particles were combining, but when we inspected it, it's not really combining, it's just growing larger, so it seems like it's combining.
Noticed from the images that I took, because once the first dip that we had revealed a lot of shapes, a lot of bubbles, like bubble-like shapes. So as we continued to dip it, immerse it, the bubbles grew larger. So they started pushing against each other, making the surface generally smoother. So as you keep on growing, the proportion between the size of the bubble and the size of the polymer itself is growing. Then eventually, until it starts to get smoother
And reaches its
a
maximum.
spherical shape. So there's no longer any spaces. It was able to maximize the expansion, the absorption. So it filled up the volume of the polymer itself.
And then you put it sa probably kasi maraming tubig.
How many coins can it take?
Oobleck.
In when I'm holding this. So basically, if you keep playing this one, it's like solid, right? And if you relax it, it's like melting. So my theory is that if you keep playing with it, the water in the oblique is rotating from one side to the other side, so it doesn't melt. So, but if you relax it, so technically the water
be submerged quickly, very quickly. But the straw, the foam, and the marshmallows were able to stay afloat. And after waiting for a while to see if they would sink or not, they were still floating. So what we did was we tested, tried to press them down.
Have the distribution of force as limited as possible. So the legs must contain only the force. We have to distribute the entire weight of the whatever cargo we put into the legs, so that those points.
We're going to use is 1 inch of cool noodle, and then on top of that we'll put a paper cup, and then make a kind of base with barbecue stick skewers, and tie them together with string, and then use that glue that Sir Charles is using over there, that seems the strongest glue. To use to stick these two together and maybe attach this, or we'll try and put some string through there on top of there.
mold, then we will add jumbo straws here, 4. Then under that we will have foam. So it's gonna make him, I think it's gonna
More stable, maybe?
yes, make stable and so for the load we're gonna add 4 cups each straws to
From the tip of the straw to the bottom of the
Okay.
foam. We'll be using cut it this way. Since when we tested in the oobleck, we tested different shapes. So one was flat, one was like this, and one we placed inverted.
Right.
The best one was
Okay.
this side. And
We'll use foam as our like the feet of the legs
Okay.
because we tried it out and it's still sinking.
Still doing it.
floating.
Still
yeah,
floating,
yeah.
right?
And even if we put the tumbler on top of it, still floating.
Okay.
so
Okay.
Giving it our best shot on that, and then we're trying to use barbecue stick to punch on the foam.
Okay.
And then punch on the cardboard.
Okay.
And then there's foam again inside
Okay.
the cardboard.
Kind of
So
acting like a
lock. Yeah,
locked
something like
in,
that.
right?
And that's it.
Okay. So you're making your cargo bay and then 4 legs. And do you have heights and things for that?
Not we're trying to measure it the best measurement, but we're not yet done. We just have to let
Okay.
you approve on this design.
Everything on the inside.
where's my snack?
What the burger?
So tell us about your design. What was your thinking?
The surface area needed to be as great as possible, but we wanted to use the styro on the bottom for sure. And then when we were thinking about legs, teacher friend said the cups would be, since they're paper, we were just thinking about using the lightest materials that we can. The skewers to make sure that we can hold
The square, so we put something under.
So that's for... Or gusto mo, sige. I don't know how you put them.
Spread, make this wider, maybe, and add another length.
What the entire...
Fine. Fine. The base, want to make it wider because it was too narrow.
So surface area is pretty important, isn't it?
Is it?
Isa mas mahaba.
What are we meant to watch for? For the
Main tower in only an hour with nothing but diapers and glue. Good gracious, Ignatius, his mother exclaimed. That's the coolest thing I've ever seen. But her smile faded fast as a light wind blew past, and she realized those diapers were in vain.
Do you want it to be just that big na lang? Or I add another one? Maybe we should make the measurements even, like kung gano'ng kalayo sila. And then we could stick some chair that teacher Norman also made. It's with popsicle sticks tied together with string again. Some skewers here to keep it in place. And then we attach bigger popsicle sticks cut to fit centimeters tall. It's attached inside by a masking tape lamp. And then there's a whole fat picture.
It's a model, but not a real prototype that could really move.
A pyramid. So each triangle is measured 60 degrees. So basically it's it's made out of plastic and metal, and also the car's wheel.
We were thinking about, since the thrust of a manual operated car is usually at the back wheel, at the rear wheels, we were thinking about
Putting big wheels at the back.
putting big wheels at the back for lighter and stronger thrust, and a sturdier front wheel with this vertical slits
Or
that
maybe
acts
in front.
as a grip, because
Trying to blow the material so it would move. We'll see if it moves faster and it would go a longer distance.
Okay.
The bottle for the body, and then some strongness, and then also if we could get the towel rags inside of these, which are thicker and smoother. A triangle, so it won't be a triangle for the car.
So the air will go here. We're gonna try the balloon, the air on the balloon. If it will be more effective, if the air will go here or.
Okay.
So you
Whoa!
Trial, we decided to put more air inside the balloon and we changed the angle of the balloon where we place the balloon itself.
We wanted everything, every detail about our design smoothed out, planned out carefully how we're gonna stick them together before we even started building.
Going through a bottle cap, which is firmly in place in the pool noodle, and then it's inside the straw, so this whole thing moves freely.
Good job.
Our balloon turned noodle, like we decided to have like sort of a frame for it to stay in place, but didn't want to use so much materials as to create drag.
As we were testing it, we found that the wheels, although they were big, they become big.
The lighter it is, it's not necessarily better. So we had to add weight or mass inside the car, so we had to go there. So just like how Teacher Francis explained it a while ago, the use of spoilers in the toy cars.
It's at the middle, and then outside the rings, we'll put the strings towards the parachute itself.
Right.
And then the one that will carry the weight will be at the center, so it's more concentrated.
How big is our trying it out right now?
Whoa! Whoa!
There, it's a little fast.
So it's really fast. So we figured it's smaller shoe on top. But then when we did the small one, like we call it ngss, because it was too small. So we chose to go with an octagon shape because we thought that it was the closest thing. Boxes, but as we tested, we realized that we needed more surface area to trap more air. So this is what came up.
And to provide students opportunities to think, to create, to recreate, to improve, in order to see things differently. If we will not give them any opportunity, then they will end up just very good note takers or very good test takers, but not.
I really appreciated our teamwork and our purposeful planning, because it's one thing to have an idea and it's another thing to have a plan, because when you have a plan, you're marrying your right brain with your left brain, you're marrying creativity and strategy, and that's what I really appreciated.
We see the holes that control the arms and the legs, and then also we see 2 gears inside that mainly control the arms and
Ears.
This acts like your sound tube, and then the tension from the string, that's the one generating the noise. So it's being amplified by the sound. So if you spin it, the centrifugal motion, so it's amplified, the vibrations on the string. So if you're using the modes of vibration on the string, and then this one is simple with concept with our bongos. There's a membrane, and then you have a sound tube which amplifies through resonance the sound waves, making it louder. So the sound so it's basically we use the centrifugal motion to increase the vibrations, but you can also do this. But it's lighter, it's lesser in vibrations gaps. So basically, it's not really fitting tightly well. The spring allows it to vibrate. So this acts like what we call a Taylor tube. So it allows the vibrations to resonate. So that's what's causing the sound to reverberate in the. If you can notice here, it's like there's a sound disc that catches the vibrations that enter. Then on both ends, one it's held here inside, so it's held by the spring. So the spring, the membrane, the catching tube vibrates with the sound waves, and it's being carried by the spring. So the spring imitates the vibrations and allows that to create more sound waves.
Oh my gosh, are you right? Are you right?
Yes.
Galing!
This whole thing,
It's plastic! Wow! I thought it would be something metal. You guys were right.
Spring.
Yeah, there's spring.
Reverberation. Completely now, since it's broken already.
So you guys were right. It's a spring. It's connected to the bottom. There's no membrane.
So our initial finding was your voice comes in here, and then the magnified sound waves come out here. So our guess was when we put this, there's a spring inside. So the spring inside acts as like the cord. Accidentally while we were trying to open it. So the thing is, there's this membrane here. It's sort of like made of
Waves bouncing back. Now, as it bounces back on that surface, it vibrates with that same frequency, and the spring will also vibrate in the bottom. Very, and then capacitor, and your coil. What is the coil? What does that mean?
the panda will move. So when we dissect the toy, we notice a circuit board that is connected in a coil.
Combines a sound amplifying na diode. Then, nice.
A small amplifier.
Electronic, electrical engineering. Oh yeah, could be already. This one's a motion detector. Ah, there's also a sensor. Nice. And this is how much?
It's
$1.
there, but if they touch each other, they will produce sounds. There used to be a sensor, I think, but it's missing, broken.
absorb more force. It allows the iron sheet to take more tensile stress than
Kaya niya mag-absorb ng force. Siya yung laging ginagamit sa rockets.
yes. So yung sa mga rockets and other automotives, like I've said earlier, it magnetizes easily. Pero di siya na-draw out kasi nakatrap pa po siya within. I-draw out ko pa lang.
So let's look at this wire that's been wound up. Whoa!
That's pent-up stored energy, and this is iron because it magnetizes.
Sige, balik mo.
Dahil hindi na kaya yun. So basically, the spring wind-up car acts the same way as tires. It also has a plastic chassis and the plastic cover. Spring mechanism contains parts as well. The plastic gears, the plastic case, our spring wind-up key, and also the flat iron sheet. So it's that tensile strength upon winding. So when the spring car is pulled back, the spring into a kinetic energy, which in turn stores it into mechanical energy, and once you release it, it is converted into kinetic energy.
The screwdriver sat here, and we saw that there were several gears inside, together with some screws, springs, and this. Basically, metal.
For 5 years. So everything is connected through like this part of the toy, the middle part. The 2 gears are, 1 gear is connected with this, what do you call this? This winding mechanism. Actually, yeah, but not quite because this is hard to take out.
Right.
It's connected to wherever the gears are. So if you wind it and then it turns, it's all like sort of
interconnected.
Yes, interconnected with each other. Let's just, can you pull it?
How does it work? How does it operate?
It operates with the use of a spring. So it's basically a claw, and once you pull on this, it's connected with a spring, and then it closes the claw like that. So when you pull on it, the action is pull, it closes. So it's translating the movement from pulling into closing like that.
Saw that there are so many parts. There are 13 actually, and you can take apart this part. It will have 3 parts, and when you pull it, it works like this. When you pull it, the spring will extend until the limit of this. What do you call this? This hole. Yes. So that's it.
Because when I did my demo for Smile, I actually did the aircraft maneuvers using paper planes. So here you could see that the wing is actually curved. One side is up here, while the other one is curved down here. So what happens is that you have drag here pushing it this way, and you have drag here pushing it this way. That's why it will go back.
It is connected to the keyboard. So it is for WASA movement and FNG. So for like that. And this one is you need to connect the earth to yourself. So this one, the 6 wire. And this one,
I'm never here.
there.
You're basically connecting the object you want to substitute for.
Yes. So it's like a circuit board, and
Learn about the materials first before actually having them create something. And the idea of how that also boosts the ownership and the confidence of children with regards to the investigations that they do. Another thing that was very significant for me and our school is, since we're already doing the 5P approach in school, one thing that I realized here is the idea that it's not linear. So you can always go back, regardless if you're in the explain part or the evaluate part, you can always go back to the other piece. And how journaling is something we're weak at in school, so I was very happy to see how journaling, either 2D or 3D, can actually help the children recall the different investigations and concepts that you're supposed to learn. And I really enjoyed the reverse engineering one. We've never explored that.
Feeling like a classroom teacher, how you presented the investigations. I loved how smooth the transitions were, like from engage to explore to explain. It's bumpless, which is very critical in classroom management. When you have 40 kids for an hour and a half, so smoother transition gives a lot of impact on how they appreciate the moment with you, and in the same manner it's equivalent to time management as well. I love the way the importance of material science was highlighted in 5 days, even if I missed one. So what do I want to do now? So as being a rebel and all, I have to infect my own sphere of influence. There are things that I cannot change, and I have to accept that. But for the things that I can, well, they better place themselves. So since I'm involved with extracurricular clubs, I've identified 3 clubs already where changes will happen. I want an enhanced Junior Builders Club investigations. I will introduce reverse engineering as part of their meetings. I want to include marketing presentation techniques for my business class club.
As the last day ends, let this be a reminder, change begins with us.
The last 4 days of training had been like a bliss, but it was nurturing, free, and innovative. It's like setting the mind that is captive of the educational expectations, free to learn on its own beautiful pace. It would inspire me to reach out to my students in a way that I would respect their individuality and make them learn on their own. A big impact also dawned on me that schools are teaching us about things and problems that are important in the 4 walls of learning, but won't really much adapt to the problems that are prevalent nowadays. So STEM is a great way of helping the kids learn to adapt to real-life situations and be able to help solve problems.
5-day training. The first one is see more, talk less. So when you're teaching, see more. So it's basically self-explanatory. The next one is let them discover, explore, investigate on their own. And last but not the least is real-life application.
Students are allowed to manipulate materials, explore their surroundings, make their observations, and more importantly, they are encouraged to share their ideas. They are encouraged to collaborate, to be creative, and to discover more, to use technology the right way. So for me, the true beauty of STEM methodology is you get the students to care, and because of this, they are more involved. Usually, students don't care, so they don't do anything in the class. They get bored easily. So with STEM methodology, they are more, since they care, they would we are feeding their natural curiosity, and we teach them the right attitude that will help them in the real world. As a parent, STEM does not end in the classroom. As a marketing person, this advocacy is also worth my while because I can build on the important connections of STEM, the methodology, and the real life applications.
Trying to relate it to modern day learning, wherein schools come up with these technology, trying to integrate computers, tablets, and then realizing that these this kind of approach isn't applicable to you can't really make it virtual, or you can't really make it digital. I mean, for us, we've gone through the old days up to old school to new school. We've seen progress, and looking at the school, at the students right now who are just experiencing the new technologies and all. I mean, either way we go, nothing beats this kind of approach. So, yeah, basically the 5 E's. We might have a little of the E's in the past, but really bringing it all together, that really makes a big impact.
So the title is 5 Days In. 5 days in, but we've only scraped the surface of change and progress and transformations. Before us, we know our challenges, obstacles, and adversities, systems and people resisting this new path because it is strange, unfamiliar, uncharted. 5 days in, and we have become not just teachers, but students, pioneers, scientists, artists, engineers, the agents of change. 5 days in, and better days to come.
Whoa.